to going to pin me. I think that works. Pin spotlight. Okay, this way I can see. And hopefully this comes out pretty well. Okay, so yeah, chapter 3 and 4. Important mindset with all this stuff is initially it's going to be confusing and eventually it somehow starts making sense. And so, ooh, whoa. Wow, that's a desk that can go up and down. All right. Okay. So chapter 3 really starts pulling it together. How was chapter 2?
I thought it was fairly easy for me just because I've done unit conversion and stuff like that in my other classes.
Right. So that's what I was hoping, but it was a good, hopefully a good practice and refresher.
Mm-hmm.
Because, and then you see these particular units, and then you start thinking about, well, how much is a meter and how much is a meter per second, things like
Right.
that. So it's a good mindset not to be too challenging. Now we start pulling it together. And we have some really simple definitions, but they're subtle, like average speed and average velocity. Those are two different things. And it's when you learn it in your physics class, it goes too fast. So I think what I'll do, a couple things. Let me say that some of the ones where I say challenging, and some of these are really taking you to the highest level.
Mm-hmm.
So the good news is that it's not going to get harder than this. But I've seen prep courses where they do really simple stuff and then people go, well, that didn't prepare me.
Okay.
So the goal here is to actually prepare you. So we've got some ratios to work with and we've got some graphs in chapter 3.
Yes.
And really the first 3 ratios are the primary thing. The fourth one is very good. They're all good. Depending on where you are, you want to move through this and then you can come back because you're going to see them. And like I say, you can have a discipline of getting through. Well, chapter 7 will be huge. Chapter 8 will be enormous. Then you would go into a physics class and really be able to learn it and be. One of our students who did that for Physics 130 last summer, he got through chapter 8 and he aced the first 2 exams without, he just kept getting better.
Awesome.
So getting an A in physics is quite an accomplishment.
Yeah, I would love to do that.
Yeah, it's possible. Just keep doing this and not give up. So, do you have a particular direction you'd like me to go, or you want me to run with it?
Yeah, just whichever you think would be best.
Okay. So let me distinguish, for example, average speed and average velocity.
Yes, please.
So average speed. Now, unfortunately, there's not actually a good letter, and as I mentioned in here, capital S, I like. But people don't always do that. And again, one of the problems you'll find is that books don't entirely lay things out enough because they would be too thick, but you need it. So S-Av, sometimes SAVG, sometimes a line above, which is kind of horrible. I'll say AVG, and that's from an earlier time to a later time. Is by definition, we use 3 lines. The distance traveled between those times and the time
Right.
between those times. So there is like, you can drive and you're going to be turning and going backwards and doing whatever. It's just how far you traveled, not how far away you got. Because you can come back, there's an average speed. Now, average velocity is by definition V, AV or AVG between 2 times. And that is different because, and we've explored a little bit, distance versus displacement. And getting comfortable with that already helps you in your thinking. Okay. Now, distance is hard. There's not so much an equation. You can do things with calculus and whatever, but you kind of just have to add it up. And if I take 1 step forward and 1 step back, my distance is 2.
Right.
I traveled 2, but my displacement is 0 because I ended up in the same place. Cool. If you're good with that, I mean, that teaches you how to, you have to really think carefully. And, you know, it's the same for all of us. Initially, I don't pick up the subtleties,
Mhm.
you know, and then I start going, oh, so I could write this like this. I could also write this like X later minus X earlier, whatever is useful.
Okay.
And by, you know, I take kind of the first chapter or 2 and really expand it here, which is going to make it, I have it. Yes. Have a podium. All right, cool. Now we're talking. That way, maybe that way. Okay, fine. Now, yes. I can move it around. Yes, life is good. So, best way to do this is by doing exercises.
Mhm.
And the best way to do that too is first you do it yourself and check with each other. Just talking with our computer science guy, who's a fantastic teacher and very accomplished. And, you know, we were talking about, we really want our students to do well. And getting this habit is huge. So let's just check one out. I could even, let's do this one. This student, I think I've done some of these on the videos that,
Yeah.
yeah. Are there any ones that I should focus on for that you would request or?
Let me see. No particular one.
How about number 2?
Yeah, sure, it's fine.
So let's get the basics. And then, so you got the basics, they get maybe a little more challenging, but with repetition. So you want to do a lot of repeated things until they start getting pretty smooth. Okay. So exercise number 2. chapter 3, number 2. Cool. So and what people, when you get good, like on an exam, you first read through it quickly, okay, and then do it. Then you do it. The other thing that's important is to know what you have at your disposal. These problems are going to have you use what you've learned, not come up with some new stuff. So somehow you got to put these to use, and you have to choose the right tool at the right situation. Okay, so think about the distinction between dimension, like time, and units, like hours and minutes and seconds. Think about it before checking the solutions on the back. Once it makes sense, it makes sense. Okay, you walk forward in a straight line the entire time. Let's analyze your motion. We're not interested in the time when you started to move from rest. Okay, a classmate pulls out a phone and takes a video after you start. You've already begun walking when we hit the stopwatch. That's an important idea. You could start a video if someone's already moving. People, there's all kinds of easy points of confusion. And that's why we got to talk about it. You can expect them to come up, you go round and round, you'll get it polished. Okay, we're going to look at the video and pause it to see snapshots every second. Okay, so that's, this gives us 4 strobe pictures. T1 is 0, T2 is 1, T3 is 2 seconds, T4 is 3, but we're doing 3.00. We're still walking at T4, and after we stop the video, you stop. Draw a ruler on the whiteboard. All right, cool. You're walking in front of. We call a position at T1 equals 0 seconds the origin, which we don't have to, but we did here, and write x1 equals 0. Okay, so I'm going to start. I kind of got this. A snapshot shows you different positions. Da, da, da. Okay, cool. Okay, and again, we'll start with basics. So this is to familiarize ourselves. So okay, here we go. I'm going to go like this. Let's see how far I go. We don't have to go right. We can go up, down, left, right. Think about it. And someone is watching, so someone is moving, and that person or object is here, moving that way.
Right.
I'm going to say T1, we're going to choose it to be 0, choose X1 to be 0. It doesn't really matter. So, and when you have 0, you don't really have to put the units because it's 0 with 0.
Okay.
But I did. But now it shows you a position X2, 1.5 meters. Let's see. And then 3.0 and then 4.5. So it's going to be equal. I'm going to go. Try to roughly, rulers are nice. Doing nice work really shows up because that's ultimately what we do on our job. And people do take notice. All right, so I've got T2 equals, and you could read again, but I know that it was 1.00 seconds, which is different than 1 second. That tells me how well I measured it.
Right.
That's the real work. That's what people want you to do. So we're transitioning from schoolwork to paid work. 1.5 or 1.50, just 1.5 meters.
Uh-huh.
Quick note. I'm always thinking because I want to get good. I want to get the job. I want to get whatever. 0.1 meters is equal to 10 centimeters, which is about a fist width. I'm just trying to train myself. It's easier. But if someone is walking, where's my position? Well, within a fist width, I'm here. So that's pretty reasonable. It's like to say within a millimeter, that's ridiculous. And even a pinky, that's
Yeah.
so this is part of this training that is often missing, and it makes it more fun. And when you go to apply it to biology, you know what you're thinking about and you stand out. And that's what we want. All right, so I got T2 is to T3. See, you make mistakes, but while you're always checking yourself, you go like this. X3 is equal to 3.0 meters. T, so whatever, still going there. There's my arrow. V1, V2, V3, V4. This is the work here. T4 is 3.00 seconds. X4 is 4.5 meters. I think that's it.
Yes.
Yes. Okay, cool. All right. Again, it's much easier than going to algebra. The physics books and even sort of the class, and when I teach it, I don't have enough time to develop this. It's not fair. And right there, whoever's had this stuff is going to be way ahead of those people that don't.
Mhm.
People that don't fall off. So we don't want that to happen. All right. Sketch the process, label it. Cool. I label it with subscripts. It's going to be so much easier. Even if books don't do a good job with this, we can be. I should always note somewhere, doesn't matter where, that I'm going to call that the plus X. You can call that the plus X, then all this will be minus. But
Okay.
so you're going to see as you develop more and more, it's really easy to make plus minus signs. This will save you. It's your friend. Okay. So now, first thing I do is have you do distance. So I'll do distance in blue because that matters here, and I'll do displacement here. So let's just kind of talk about this. I'll write it up real quickly. Distance 1 to 2. Distance, I said 1 to 4, 2 to 3. 1 to 4, 2 to 3. Can you see that? Is that big enough?
Yeah, I can see it.
Okay. And 2 to 4. Okay. So if I look at distance, I go, okay, from 1 to 2. Now this one's it can be confusing because it's so obvious in a way,
Okay.
but we're going to build. So from 1 to 2, boom, boom. Well, you went 1.5 meters.
Right.
From 1 to 4, I went 1.4, okay, 4.5 meters. From 2 to 3, I got to go, okay, I went 1.5, 3.0 meters. But that's only because I went straight. If, for example, from 2 to 3, you started going this way, you turned around, you went there, you went back there, you go like this, all that is added up distance.
Uh-huh. Yeah.
But in this case, we just went straight. So it's kind of cool. And 2 to 4, oops, 2
Would
to
2 to 3 be 1.5?
yes. That's why you needed friends. So, you get a phone call, whatever. So you go back to it. And really, on an exam, you're stressed. But if you write that stuff down, you do catch your mistakes, and other people can too. Okay, so for displacement. Oh no, I did the wrong color. Oh, I hate myself. Okay. All right, never mind. I'll just go ahead and do delta x 1 to 2. In this case, my displacement, now I could write this. Let's do 2 to 4.
Okay.
Delta x 2 to 4. And you really know something when you can do it a couple of different ways.
Okay.
So I could go, oh, well, that's x later minus x earlier. in general, E and L, but when I apply it, put in the numbers. And that's 4.5 meters minus
1.5.
1.5 meters. And of course, that's 3, not 3, but 3.0 meters. I could also do it because I could see that I went from here to here. And so I don't really need all that. So you can write that if you wanted to prove it and you want to be careful. But you can also see in this that the displacement from here to here.
Okay. Yeah.
And then I'll say too, that again, if here, what you actually did was went like this, went like this, and went like this, and went like this, you still have the same displacement. Because displacement doesn't care how you got there.
Right.
Distance does. We good?
Yes.
Cool.
So in this scenario, distance and displacement is essentially the same because we just went in a straight line.
Yeah, and that's the one case. But, and even if I stop, I'm not getting more distance and my displacement isn't changing. I keep going, but the minute I go back, I add distance, but I have negative displacement.
Right. Okay.
And so then I simply take those numbers and divide by the time, that should be blue, to get the average speed and the average velocity. And in this case, they'll be identical. We good with that? Does that make sense?
Yes, it does.
Yeah. So now though, let's see. E, put velocity vectors on your sketch at all 4 instants. I did. And displacement vectors, 1 to 2, 1 to 4, 2 to 3, 2 to 4. Okay, I made a mess. So I want to be able to show this. And trust me, when you throw a ball and it's got a horizontal displacement and vertical, and it might start here, but it ends up here. And,
Oh, yeah.
but it'll get easy because you just go, oh, of course. All right, so 1 to 2, that is simply from here to here, delta x 1 to 2. Again, like I say, it will get more complicated, but if you break it down like this, you'll get fast. 1 to 4, well, delta x 1 to 4. Delta x 1 to 4. I mean, this is what people that are good and doing real work, they keep track, make it clear. 2 to 3. Delta x 2 to 3. 2 to 4. Delta x 2 to 4. And while it's tedious, if you really want to get good, like in an instrument, you do the basic stuff really well. Okay. You still walk to the right, but for whatever reason, you chose the direction left to be the positive. So now, if I take this out and I go, this is positive, then what happens is my position will change to negative.
Right.
Because I'm moving in the direction I call negative.
Uh-huh.
My distance doesn't change. My distance is still positive. You still got exercise. But your displacements are all opposite. The arrow for displacement is opposite the arrow for your positive direction.
Right.
And again, when it gets complicated, if you've got this, you won't make the mistakes that make you frustrated and feel, so often people think like, I can't do physics. It's like, well, what exactly? And usually without a course like this, it's just a blur. Like, I don't know what I'm lost. I don't know what I'm doing. because people try to jump to the equations. Is that okay so far?
Yes.
Okay, cool. What changes, what does not change? So the plus minus of position and displacement changes. Those change to negative. Distance stays the same. Yeah, so the next one, if you had the snapshots without the video, or seeing them walk, could you tell if the walker ever changed speed? No, you don't know. You just see this and then this and then this, but you don't know what happened in between.
Right.
So we have to describe that. And, the intro physics, you don't go crazy with it. Okay, so that's a good start. That's your basics. And then I have you doing this at different time intervals. And I think still walking in the positive direction, whichever way that is, on the next one. And again, by doing it, eventually something in your brain clicks and go, oh, this is easy. Then on number 4, I've got you shopping. So for shopping, love this podium. Yes, this is great. For shopping, it's like, I'm going to get this. And then you stand there or whatever, and they go, I'm going to get this. And then you go back and you go, I got to get this. I got to get this. And in that case, we're just going to look at average speed and average velocity doing the exact same thing. See the picture. Guys, this is training your awareness of, this is really physics. Manipulating equations is not physics. That's algebra.
Yeah.
And it doesn't really help you when you go to apply it in, say, physiology or whatever. I mean, it does come up. So thinking about process is profound. So profound. I just had it open on my desk, a thing on modern physics. And the first thing they talk about is Galileo, how important it was to break this down. Okay. So I think I've got that video. Let me do this. And then touch on that. Yeah. Number 6, Galileo changed our world. And there were other people that did things. And people did a lot of things that build pyramids, which makes sense because if you want to build something tall to boost your ego, the simplest structure is a pyramid. People make it all mystical. It's like, well, you don't want it to fall down because, you're the root.
Mm-hmm.
You're the ruler. Now, if they made something they did make some really tall things, obelisks, but they were narrow. Anyway. Okay. Let's just do this real quick thing. I'll do it over here. As an example. Just make an example. People think they're making it easy by always doing things like choose plus to the right. And in fact, it makes you weak. I'm gonna choose. Now you know what I'm doing. I'm gonna use units of meters for walking. It can be centimeters, inches, whatever. And I'm gonna say that I start here, squares or circles. I'm going to start at rest. So I'll say T1 is 0, and I'll say V1 is 0. Start at rest. And then I'm going to go out here. This will be an interesting one. T2 is, I don't know, give me a time.
15 minutes.
15 minutes, okay. So that's actually good too, because I might go, okay, do I want to work in minutes? I can work in minutes. Let's see what happens. I love that. And V2 is 0. I get to come to a stop too. I could break that down, but let's try this. And then how far did I go? Let's see. Well, 15 minutes later, I don't know, let's do 3.25 miles. Cool, you got me going now. All right. Now, here's what's kind of interesting about this. If I do average velocity from 1 to 2, the first thing you do, and this is, believe me, we all have to, I work with university students and look how they think. People tend to jump too far ahead. Write down what you know. That's one of the biggest steps in problem solving. Write down what you know and know your foundation. So I know that that's delta x from 1 to 2 over delta t from 1 to 2. Now, in this case, I went from there to there. By looking at it, that's negative 3.25 miles, MI for miles. The negative matters because then if you keep doing calculations and you made a mistake there, everything's a mess.
Yeah.
You know, you do horribly on the exam because you made a simple mistake. We got to train that. And the time, of course, is 15 minutes. So my answer is negative 3.25 divided by 15 miles per minute. I can convert to second if I want, but I like this as an example of how you don't have to. You can convert to hours. So let's see, that's equal to a quarter of an hour, 0.25 hours. 2 sig fig, 2 sig fig. If you're good at this stuff, you will stand out. Oh, thank you. Part of, you get good at stuff when you do it over and over. And sometimes as a professor, you might forget that people haven't been doing it as long as you have. And I can also see that I'm going to get a number here. I have 3 sig fig divided by 2 sig fig. So I should equal negative 2 sig fig number miles per minute. Even though the velocity is 0, here and here, you did have an average velocity. I mean, you were traveling. So that could be confusing to you. Go, well, I don't know, my average velocity is 0. 0 plus 0 divided by 2 is 0. That's not how you do average velocity.
Yeah.
Unless there's a constant acceleration that does come up a little bit later. But here I had to have got, increased speed. I had to step on the gas pedal and then I had to step on the brake somewhere, or I had to start running and slow down and stop. Distance. If you went straight, and it doesn't even matter if you stop, if you go straight and stop and keep going straight, your distance is this, and it's the same time, so the distance would be positive. However, in 15 minutes, you could have turned back if it's one-dimensional. And then I don't have enough information. So I would say, I make little notes, like on an exam, sometimes professors write them too fast. And they don't take what's in their head on the paper. And you either ask a question or you make a note. If the person keeps going in the same direction, then the distance would be positive this divided by the time.
Right.
Is that cool?
Yeah.
And then it's like, I don't know, let me have it. Just give me whatever you got. If it goes from here to here and that's 2, and this is 1, 2, 3, and then over here is 4, whatever, it's just this, right?
Yeah.
And you've got it. And that itself is a big deal. You do the same thing for average acceleration, except it's change in velocity over change in time. So it's a nice little ratio. It does start getting easy. You guys can do this. But there are puzzles. And, I didn't solve every puzzle that was thrown at me until I got some help.
Yeah.
Oh. And one of those puzzles comes up on number 5, walking your dog. Okay. Oh, and I think also someone is going to come by at 1:30. So walking your dog. Here, the hint is you can solve this whole thing using distance and displacement, average speed and average velocity. But you have to visualize the process. And I think I've got this one posted. But let me just help with that one. The neat thing about physics is there's not nearly as much to memorize as you biology folks. It's like, here all those bones, man. I like it actually, that stuff, but memorizing, it's like a language. So there's some basic stuff that you apply problem solving. And so here's a problem solving thing. If I don't care where you are, Berkeley, here, if this problem were put on a test for like our physics 120, they call it 8A at Berkeley, 120 at San Francisco State, at least half the class wouldn't get it. A lot of people will leave it blank. And that's the thing you don't want. You go, okay, I don't know, what do I have? Let me see where it takes me. And then I might bail on it because I'm running out of time. I'll do another problem. But I know I get partial credit because it's about problems. Okay, I know I'm going to read through it quick and then go through it slowly. It's the fastest thing to do. I'm not going to jump to equations. It's death. Okay. You take your 2 dogs for a walk down to the beach. Walk up to a sign that says this, to the beach. As usual, Chuck stays close, Buddy bolts. Those are my 2 dogs. They passed away, but using your drone to follow Buddy, which would have been helpful because they're husky. You run straight to the beach and back to you. Now, straight to the beach doesn't necessarily mean straight line. So it gets a little tricky. Buddy doesn't return to that sign. He returns to you. So check this out. Here's my blue-eyed husky Buddy. And then here's you. And so, we're going to get to a sign. So I just start writing this out. Like, what am I talking about? 2 miles to the beach, 2.0 miles to beach. I start off here. I don't know, Y for you or M for me or whatever you would do it. We don't care about Chuck. Buddy. And the beach is over here, some water. But the path, I don't know. It turns out doesn't matter. Could be straight, could be like this. So the 2 miles is along the path, how far you have to go. Think physically. And I slow down, try not to jump too far ahead. Buddy takes off, and Buddy does this. Now I'm going to call that state 2. You don't necessarily, but that's kind of, and I'm going to call this state 1.
Okay.
And again, even if you don't get it the first time, you mess something up, you'll go, oh, I messed that up. Not, I can't do physics.
Yeah.
And now you're going to learn. And while Buddy's doing that, you're walking. So that's you at state 2. Buddy already got there. You're just walking, you and Chuck.
Yeah.
Well, Chuck's not doing anything. And then Buddy runs back to you and you're still walking. So there's 3. And Buddy comes back. You guys are together there.
Yeah, I told you.
So this is a really good puzzle. But you can get it. You might not have got it the first time. That's okay. All right. You walk at 2.0 miles per hour for 15 minutes. Hey, there's your 15 minutes again. So the velocity of you is 2.0 miles per hour. I'm just going to write down everything I know. It's a puzzle for 15 minutes. Now I got to think 15 minutes. What is that the time for? Oops, min, can't say meters. What's Buddy's average speed? Is your answer reasonable? Okay. So that could be a good question. Like, do you mean from 1 to 2? But if you read it closely, it's going to be the whole time, 1 to 3.
Okay.
Now, since I don't know the path, it's a little hard to, I mean, my displacement, for example, from 1 to 3 is here. That's your displacement.
Mhm.
But along the path, I can talk about distance. This is a little funny because really, it says in here, if I look again, which we often have to do, that's the puzzle, that's kind of the fun little struggle. I go back to it and it says, you have walked at 2.0 miles per hour. But you're changing direction, right? So it shouldn't be V. It should be the speed, which again, books don't take the time to, that's your speed,
Right.
not the velocity, because your velocity is changing. I'm not sure what I did in that. Okay, so that tells me, look, all you have to do is go, well, let's do for me. What are my tools? I don't know. I got speed, I got distance, I got time. let me just see where it goes. So I can go, the speed of u average is the speed of u, because you didn't change, I guess. And that's the distance of u from 1 to, let's do 3, over delta t 1 to 3. I know, I just start messing around. This is the puzzle part. I know that, I know the time, I can find the distance. I could put it in seconds if I want. You know, that's 1560 seconds,
So I am an guy.
whatever you want. But then I got hours. So maybe I don't want to do that. Maybe I do 0.25 hours. Because then I got hours.
Yeah.
So you get, you know, I mean, like all of us, like me with guitar, like I'm stuck, and then it starts, you know, becoming easier. And then you get stuck on the next one. So, oh yeah, I could do that. I could put, then my speed times my time was distance, and I could then go distance of me 1 to 3 is equal to my speed times my time. That's 2.0 miles per hour times, well, a quarter of an hour. I'm going to put it in decimals, but that's a quarter, so it's going to be half, 0.5, 2 sig figs miles. Notice what I did. I did a little fast, but just for this, I have 2 sig figs. I have 2 sig figs. 2 sig figs. I put into 2 sig figs. We're not super picky about that, but having some awareness. Oh, you're next? You're coming in? Okay. When do you start?
45.
Okay, good. I'm out of here. Okay, cool. So there's that. And then you've got, you can do the same for Buddy. His average speed,
Mhm.
the distance is 2 miles plus whatever,
Yes.
and which is 2 miles plus 2 miles minus that. And you got the time, and you can mess with it. So let's move out of here. Come on in. Come on in, shower. Sorry. I had this, I realized like yeah, my board in my office is too short.
Oh.
And AJ came in, it's like, yes, I'm so excited. I'm excited to do physics. I found this, and
Oh yeah, that's the video.
yeah, that's pretty good. So at least we have our room, you know?
This floor is much better.
Yeah.
Several things.
Yeah, cool. All right, so I stole those pens. All right. Cool. See that? Physics 120.
Yeah. That's
Yeah.
one.
Yeah, this is 120. We're doing 101, so that she's gonna be so prepared for, it's gonna be crazy. Okay. So that problem solving part is the part where you have to have that confidence, like, let me just put all the little pieces out. But you know, it's funny, we do it with a puzzle, like you don't expect to look at the pieces and do it in your head, but we're not, and I think that's the issue. It's sad, we're not trained to do this in school. That's one. And two is, we often haven't matured to that place when we're younger. So you can only do so much with kids.
Yeah.
But still, if you could train this where things are not just tell me the answer, but figure it out. I'll give you a couple tools and figure it out, then I think we'd do better. But we're not used to it. So And then there's graphing,
Yeah.
which is the other part of that. And doing the graphing will really teach you how to graph. If you do these exercises and you keep doing it, and it's another thing that we don't spend enough time on in class because we don't have time, but you have to learn it, especially for engineering and biology.
Yeah.
Graphs are just really useful, and once you get used to them, it's like a language. You could just, you know what to look for. So you're good for that. So how was that?
I think the graphs is what I needed a little bit help with, just because I'm used to the graphs like in biology and stuff, but this has